Ship leaves port at noon, has a bearing of south 29 degrees west. Okay, so I'm going to call this my port, and the boat starts at the south line, turns 29 degrees towards the west line. So southwest, the boat is headed this way, 29 degrees. The ship, so this arrow represents the ship's path. The ship sails at 20 knots, which is very similar to 20 miles per hour, but it's in the water. How many nautical miles did they travel west? And how many nautical miles did they travel south by 6 p.m.? Okay, well, for my west and my south, I want to know how many miles. Nautical miles just means miles in the water. And if these are supposed to be lengths, by the way, we have a right triangle. If these are supposed to be lengths, I want this to be a length too. 20 knots is a speed. So if you go 20 knots from noon to 6, you did that for 6 hours. 20 times 6 is 120 nautical miles. Okay, so now it almost looks like one of the questions on the first page. We've got a right triangle, we've got a side length. We want to find a different side length, so SOHCAHTOA equation, but we need to know one of these acute angles. So what about this one? How could we find this angle? That was 29. So 61. Okay, and so if you're trying to find how many miles south they went, looks like you're trying to find opposite when you know hypotenuse. That would be sine. And if you're trying to find how many miles west, that's adjacent when you know hypotenuse. So that would be cosine. And then the hard part's behind us. Multiply both sides by 120. Yes, Kai?
How did you know to subtract 29 from 90?
Because of my picture here, to use SOHCAHTOA, I need an angle in the right triangle. This 29 came from here, the bearing. And then these two make up a whole quadrant, so they had to make a right angle.
Okay.
Yeah, but it was not given to us. We just had to see that we needed that and then reason it out. So if you had that bearing at that speed, you now know how many miles you actually went south and how many of your miles went west. You know how that's being divided up. So to me, I'd say the part that you might want to practice again is setting up the picture. I feel like once you guys get the information in there and the SOHCAHTOA equations, you practice that enough that you should be good there. But the picture is a little unique.